All right, so we're going to continue with exponential functions, and we're going to talk about growth and decay. So growth is more like increase, so like we're increasing, and decay is when we're decreasing. We're going to talk about each of those items today. So we're going to start with exponential growth. So, right, so growth can be modeled by a function y equals a times b to the x, where, as always, a does not equal 0, or actually this says a is greater than 0, and b is greater than 1. The base, so our b is what we consider our growth factor, or as we referred to it in the last section, our common ratio. All right. As a graph, an exponential growth would look like this. Again, we're not going to cross the x-axis, but we have a b that is greater than 1 and an a that is greater than 1. And then something that it points out is that when we're looking at y equals a times b to the x, that this a is our initial value, so like our y-intercept, right? But not for for a curve, not a line. And then we have our base and exponent. Now, why is this important? This point right here at the y-intercept bothers me that I didn't put arrows. All right, this point at the y-intercept, that is 0, a. So if we think back to the problem we did in the last video, or in the last section, when we made the table, when we plugged in 0, we got the a value of 3. And so we had a point 0, 3. All right, so that's information about growth. And again, b is greater than 1, meaning it doesn't, like any number greater than 1. If it's a fraction greater than 1, it's still growth. So now we're going to use this. Since 2005, the amount of money spent in restaurants in the United States has increased about 7% each year. In 2005, about $360 billion was spent at restaurants. If the trend continues, about how much will be spent in restaurants in 2015? So we're going to be working with y equals a times b to the x. X is our years since 2005. Remember that a is our initial value, and b is our growth factor. So when we look at this, we increase about 7% each year. So that means that b is going to equal 0.07, because that is the representation of 7%. We are increasing by that much. So we're actually, because we have to be greater than 1 to be a growth. But if we take anything 1.07, the 1 keeps the number that we had, and the 0.07 automatically adds the 7% to it. That's how percent works. So like when in 7th grade you guys were doing percent increase and you found the percent you were increasing by and then you added it back. Well, if you would have just put a 1 in front of your percent and then multiplied, you would have gotten your answer a lot faster than setting up a proportion. Anyway, why we don't teach it that way, I don't know. But then we expect you to know to make this 1.07. All right, so, but again, this is the fact that we want the original amount, which is times 1, plus the 0.07, which is the 7%. And our initial value, A, is that we started with 360 billion. So, if the trend continues, about how much will be spent in restaurants in 2015. So now I need to plug in. Y equals 360 times 1.07x. So our x is going to be 15, or not 15, 10, because I'm going to take 215 minus 2005. It's been 10 years. So we'd have 360 times 1.07 to the 10th power. And so plug that into the calculator and we get 1.07 to the 10th. That didn't look right. 1.07 to the 10th power times 360. All right, so what we end up getting is y is approximately, and I ended up with 7.0817, and it wants to know about, and so, did I say 7.708.17, which is approximately $708 if the trend continues. What is an expression that represents the equivalent monthly increase of spending at U.S. restaurants? So what we are going to need for this one is that we need to find where R is approximately the monthly growth factor and M is the number of months, because it wants us to do a monthly increase. So we know that 1.07 is our growth factor, and X is the number of years. So what we're going to do is, I know that that is 12x over 12, because there's 12 months in a year. And so then what we're going to do is we're going to do 1.07 to the 1/12. And then we're going to pull the 12x to the outside. We call this factoring. I'm just going to bring the x to the outside of everything. And so now we're going to find the 12th root of 1.07. So when we find that 12th root, we're going to end up with 1.0057 to the 12x. And then we simplify, which will give us 1.0057 M. Because we're changing it from 12x, right, to months, maybe if I can get an M written in there, where 12x equals M for months. And so this is the expression for an equivalent monthly increase in how we would find how much we increase each month. That was a lot. And I'm sorry, because in all actuality, it really doesn't take that long. I'm going to do this compound interest as its own video. I will see you in the next video.